Let's look at this sample problem here. We have vanadium can form several different compounds with oxygen, including, it's supposed to, the smartboard software here is, it's supposed to be V2O5 or VO2 and V2O3. Determine the number of moles of oxygen needed to react with 0.56 moles of vanadium to form vanadium 5 oxide. So, we always want to start off with the equation. So, we are combining vanadium with oxygen. Vanadium is not one of the diatomics, so it's just V. Plus oxygen, which is diatomic, so it's O2. To produce vanadium 5 oxide, which the formula comes out to V2O5. Okay, now, questions given. Determine the number of moles of oxygen needed. Okay, so number of moles of oxygen needed, so that is the X moles, right? And we are mixing it with 0.56 moles of vanadium. Okay. So, remember what we said, we always want to start off with our table, right? So we're going to, what are we listing? Okay. So we've got moles and we've got molecules. So, which one are we going to list first? We're going to do that in a sec. We're going to do that in a second. So, which one are we putting first? Oxygen, right? Because it's the one that we're trying to find. And then we put vanadium. So, we don't know the number of moles of oxygen. So that's our X. What are the moles of vanadium? 0.56. How many molecules? This is where we balance. Okay? So now we're going to balance the following equation. So take a second. Balance this equation. When we're balancing it, what do we get? How many vanadium? 4. How many oxygen? 5. And how many vanadium 5 oxide? 2. But now we don't really need this. This is not being asked in our question. So the ratio is based on this to that. Right? Based on that to that. So we have how many molecules of oxygen? 5. How many molecules of vanadium? 4. So remember what we said? When we're writing out our equation, we treat this as if this is the equal sign. Right? So we're separating X over 0.56 over 5 over 4. So, we isolate for X. Okay, we isolate for X. And we're given 0.56 mole of what? Vanadium, right? Vanadium. And we're going to multiply it by 5 molecules of 5 molecules, okay, of oxygen over 4 molecules of vanadium. Okay, so molecules cancel out. Vanadium cancels out. All I'm left with is moles of oxygen. So when I multiply 0.56 times 5 and divide it by 4, what do I get? 0.7 moles of oxygen. Now, least number of significant digits in my question? I think it's 2. Right? So this answer is 0.70 moles of O2.